Let's take a look at a nice simple equation. Let's say that a ball is being thrown off of a building that's 100 feet high and it's thrown at 15 meters per second velocity initial. So it has an initial velocity of feet per second, not meters, because I'm going to measure this in 32.2. So our gravity is 32.2. Our velocity initial is 15 feet per second squared in the x direction. So the question we're going to ask is how far down range does the ball go? So how far away from the building will the ball land? Okay, so we can use our time equation that we learned in our last video. So this is the time the object remains in the air. So if we put our initial conditions in here, we can find the amount of time. Okay, so if we look about this, this is going to be our theta right here, and our theta goes all the way down to 0, so that means sine 0. So our two sines, this sine is 0, our sine squared over here is 0. Doesn't matter about your initial velocity. So this ends up being 0, 0. So you end up with time, in this case, as being like 2 times g, which would be 2 times 32 feet per second squared, right, times the height, which is 100 feet, right, and then we're going to divide that by 32 feet per second squared, and this is going to end up with, fortunately, with all these feet per second squared and the feet, that comes out to be second, which is really great, which is what you always love to do when you multiply this out. I'm sorry, you got to take the square root of this thing yet too. When you multiply this thing out, it comes to be the 6440 square root divided by 32 feet per second. We want to get rid of negatives because I see this would be a negative and this would be a negative. You don't want any negatives under the square root because that's just too much problem. So you want to pull that negative out. This will be a negative down here, so that's why we end up with two positives. 6440 divided by 32, which is going to end up being like time is going to end up being like something like 80 divided by 32. And then our time is going to end up being actually about 2.5 seconds. Hey, there you go. That's how long it took for it to go from here to here, right? 2.5 seconds. Let's use that. Let's put our 2.5 seconds. And now that we know that we know the total time it took for the ball was in the air is 2.5 seconds. All we got to do is plug it back into here. And we can plug it in here as well. It doesn't matter. When we plug this back into here, actually this becomes 0, which makes sense because the ball's at the ground. There's no more height to it anymore. This is our height side. This is our J side. So this actually would be 100. This is a 0 because your theta is 0. 1/2 would be 16 times 2.5 squared, which is actually 100. So this ended up being 0. So let's find out what it is in the I direction because that's how far down range it is. So we're going to have our velocity initial, which is 15 feet per second, times the cosine of 0 degrees, which is just 1. 0 degrees, which is just 1, times our time, which is 2.5 seconds. Is that correct? 2.5? Yes, it is correct. 2.5 seconds. And this is going to be our downrange. Our downrange is going to end up being about 37.5, around in there. 37.5 feet. And this would be our I direction, and then actually if you want to put RT here, you can really, if you want to. You can put RT here if you'd like to. This would be 0J. So that's actually, this would be our time function for this particular problem. Okay, nice easy problem, really helps. You don't have to worry about, you don't have to use any kinematic equations, you don't have to use any of that kind of stuff. If you just know these two, boom, you're done. You can, no matter where it is. You can put any time you want in here. I don't care if you could put 0 seconds, you could put 1 second, you could put 1.2 seconds, whatever the case may be. And don't forget that your R of t is always going to be here somewhere. Somewhere in here is going to be your R of t, right? This is going to be at a particular time. Whatever that time is, it's going to be a particular time. That's where that R of t is. And you're also going to get a direction as well. All right, so hopefully that helps. Nice, easy Nice, easy problem. Piece of cake. Thank you.